All right, let's go ahead and take a look at this next one, guys. It says, suppose a radioactive substance decays at a rate of 3.5% per hour. What percent of the substance is left after 6 hours? Now, let's go ahead and actually take a look at the information. So first of all, it says that there's a decay at a rate of 3.5 per hour. So in this case, this substance here, it's not growing, it's actually decreasing by the hour. And they actually want us to find how much is left after 6 hours. Now, there is a bit of a problem here, guys. They're actually not telling us how much of the substance there is. But if you're starting off in this case with something with any product, we're assuming that this substance is actually at 100%. Now, I could actually create a table in this case. Let's say if I want to go ahead and create a table, or before creating a table, let's actually label X and Y. X in this case is going to be representing time, once again, in hours. And the Y in this case is actually the percent of substance left. Substance left. All right. Now, like I said, in this case, they're not really saying how much of the amount we're having. So if I create a table, we have X and Y. At the 0 hour, we should actually have 100% of the substance. Once again, whatever it is, it's not really giving exact measurements, but we're going to be given 100% of whatever is offered. Now, at the first hour, we are going to have a decrease of 3.5%, which means it's going to go down. We have to subtract, and that's going to be giving us about 96.5, assuming I added correctly there. That's going to give us 96.5, and then we move on to doing all the way up to probably 6. Now, we could do this table in this case to check, or we could in this case create a table, not a table, sorry, an equation that could help us solve for how much substance is left. Now, in this case, whenever we're creating the table, not the table again, the equation, we are going to start off in this case with y equals the initial value. And we're going to go ahead and actually multiply that by 1, because once again, this represents the whole of the initial value. So you're starting off with the entire substance, and then from that substance, you're either going to grow or decay. In this case, we're actually going to be subtracting, so it's a decay. Now, once again, we're focused on subtracting 3.5%. So we actually want to go ahead and convert 3.5 into a decimal. Once again, we move this decimal 2 spaces to the left, and we now have 0.035. So we're actually going to go ahead and subtract that from 1. And then we're going to go ahead and raise that to the power of x. Now, in this case, instead of actually writing that 0.035 there, I'm actually going to go ahead and replace it with the rate, whether the rate in this case r equals rate, whether it's going to be increase or decrease. So let's go ahead and substitute those values in. I have y equals 100% of our substance times 1 minus our decimal, which is 0.035 x. All right. Once again, this was the decay, the rate of decay in decimal form. So let's go ahead and simplify that a bit further. I have y equals 100 times, what is that going to give us? Let's check. Let's check, because I could be wrong. Let's see, 1 minus 0.035, which in this case is 0.965, and that is x. That is x, and then it's actually that same one. I just needed to convert it into a decimal here. So in this case, we want to go ahead and see how much of the substance is left after 6 hours. So we're going to go ahead and say that x in this case is going to equal 6. So let's go ahead and do that basic substitution. And I have y equals 100 times 0.965 to the 6. And let's go ahead and enter that in the calculator. And that's going to give us 100 times 0.965 to the 6th power. And in this case, we actually have about 80.75375, yeah, about 80.75 of the substance left in this case. That's how much of the substance is left after 6 hours. That's how much is left. And that's in the percent. All right. And in this case, guys, if we would have actually been decreasing this all the way to 6, we should have gotten the same thing. Same thing here.